Hello everybody, my name is Seamus, my nickname actually. I just picked up this Lionel motor. It's a simple motor that Lionel used. It's actually a pre-war motor, which was made before World War II. These motors come in a lot of different configurations. They're called series wound motors. And before I look into anything, I just want to make sure this thing works electrically. So I am going to take you just through that part in this video. And my later videos will show you how we can actually get this thing running and on tracks. Okay, now these motors can go bad one of two different ways. And like I say, I want to check this electrically, because if the armature in here is bad, then basically this motor, to me, it would be no good, because how hard it is to get this particular armature. There's other model motors that Lionel make that, you might be able to get an armature, but to me, if that armature is bad, I'm going to have to try to find a new one. So before I go into anything else, that's why I want to check it electrically. Now, here's a motor that with its wheels on and everything. So what we want to be able to do to check this electrically is we got to make sure that this can spin. The armature can turn by hand. You see, this has no gears, no wheels, just the one gear on the end of the armature. This one here has everything going for it, and it does spin. So if you have a motor like that and you want to check it electrically, that's fine, you can do that. But if it does not spin, that might mean there's something mechanically wrong with it, and you would have to investigate that. It could be a bad gears on the wheels back here, possibly a bad bearing in here, or a bad bearing on the other side. Actually, this has no bearing, it's just a hole, but some of them do have bearings on the other side. But like I say, if it's jamming mechanically, you might have to take care of that first. On this one, I would probably, I don't know, maybe back the wheel out and pull this gear off. But like I say, this one does spin. So let's go back to our original motor here. Okay, before I proceed to my electrical test, I'm going to look for any obvious things that'll stop this motor from running electrically. And I noticed the first thing here is, I know it's tough to see, but you will see it on yours. Right here where this wire is on the screw, by the way, I replaced those two wires, but right over in there, that's very close to the metal ground. And also, the brushes only have a very little gap in there. It might, hurt us in the long run. So anyway, I find on these motors, by the way, these are humpback motors. I'll show you the difference in a little while from other motors. But yeah, the brush holders are way too close right there. These plates, I find that they bend somehow or other, and I try to unbend them, and if all else fails, I put washers or shims under these screws right here and the one on the other side to see if I can get, a nice gap by that screw and also on the brushes. And the gap should be even, especially on the brushes. I mean, it'll run, but you're going to wear your brushes out a lot quicker, and depending how bad it is. But yeah, those brushes should be hitting the armature face pretty evenly. Okay, so anyway, there are wiring problems here. Like I said, I replaced these two, but the wire from the pickup down here, which is soldered underneath here, and when I go over the plates in my next video, I'll show you how that's done, but we're not going to need that for that test, because I'm going to go, normally that wire would go on these motors anyway, straight to one of the brushes over here. So, we're not going to use that wire, but let me open this up. I'm going to take this brush plate off and try to straighten it out. But before I do that, I want to clean the armature face and the brush holder wells. Alright, as you can see now, I have the brush plate off, and I want to clean it up because these brushes they spread dust all throughout here and it affects your running. So it's always good practice to keep them nice and clean. What I got here is a Q-tip. I usually pull off some of the cotton because I don't want to wreck anything in here. Now you can see the springs in here. I want to watch out. I don't want to catch them either. Now what I use, you got to be very careful with, but it does remove all the grime real easy, is I use lacquer thinner. Just try not to get it on any plastic parts or anything. And go ahead and swab your Q-tip down there. This one is actually clean, but sometimes they come out so dirty you use 3-4 Q-tips sometimes. Yeah, that's very good. Anyway, try to get both sides, and that should be pretty good. But like I say, I really see them real dirty sometimes. Now here's the other part that we want to clean up, and I have my own method for doing this. Once again, I use my Q-tip, a little bit of lacquer thin. I really want you to be careful here, because just try to get it on the face to remove that dirt. There's other people who use other things. Some people use isopropyl alcohol. I think you can get it like 90% pure or something. But anyway, try to get all the grime off of it. And we are going to polish this up in my next step. I just like to get the grease off of it. Okay. Now there's a couple of things you have to watch out for this armature plate. If it's got any grooves in it, if it's got grooves, you're going to have to take a piece of fine emery cloth and just hit all 3 segments up. Try to get it nice and clean, nice and flat. And this one actually seems pretty good. Very, very few grooves in it. So what I do with these here, especially since I don't want to take this one out because of the gear, but there are some that you can actually pull the armature out. And that's handy because you could put it like in a drill press or something and just lightly with the emery cloth. Okay, but what I do here, seeing as it's in, I use my little polishing tool here. You want to be careful with this too. You don't want to, have it hit anything and destroy anything, wires or something like that. But I like to get them nice and clean. It's a soft brush. By the way, I'm doing this on this motor. It's not the one we're going to try to get working because I had already cleaned that one. And I wanted to show you a dirty one. You want to try to keep it even, so, don't stay in one spot too many times. But, yeah, that looks nice and clean now. Get some of that rust off. Okay, now the next thing you want to do is, there is like insulating things between these parts of the armature. That's these segments here. So you should get a pick and make sure that they are clear, all the dust and stuff. You also have to make sure that there is a slot there, that the copper is not so worn down that there's hardly any slot. Alright, that seems nice and clean. See how we... That's it. One other thing I did want to point out to you guys is that what I was saying about this motor, it's called a humpback motor, and it's probably the simplest, one of the simplest motors Lionel ever made. But it's different than, like, say, this motor. You see, this is the stator side of the coil of the motor. You see how many plates this has? Well, these humpbacks only have 7 plates, which correspond to the 7 plates in the armature. That, I don't know, I'm not going to be able to see that there. But anyway, that's one of the things that makes them so rare, is that 7 plates. Okay, I think we got everything cleaned up now. So, let's go back to our original motor. And you can see these spins pretty freely. Sometimes this bearing back here can get tight, so you got to watch that. You can put a drop of oil in it if you wish. Okay. Okay, so I made a little drawing here of what I mean by a series wound motor. That power from my transformer or my track is going to come in here to the brush, into the armature, out of the armature, the other armature brush, down through what they call the stator coil, and then somewhere on the end of that, that's going to be grounded to the frame. Here it is in real life. Power is going to come into this brush, through the armature, one segment, then the other, out of the other brush, and from out of the other brush, it's going to go to the stator coil. That goes in right at the top here, and out of the stator coil, on the other side, somewhere in here, you'll look around, you'll find it. That is grounded to the frame of the motor. So you can see, you have a continuous AC current going through, all the way back, all the way to the frame of the motor. Okay, so this is probably our most important part. I always keep my fingers crossed when I get to this. I want to check the armature. I have my old trusty Simpson 260 here. It's an old meter, but it works perfect for trains. I have it on DC. I'm going to go to the R times 1 scale. Then I am going to zero out my meter. Okay, now you can use other meters too. You can use digital meters and stuff. I've just had this for so long. Alright, now let me show you. The 3 segments of the armature. There has to be continuity between all 3 of them. And there you go. And it should be about even. That there's like a little over 1 ohm. Then I go to this one. That's about the same. Then I go to these two. And that's good. That's about the same. So, one more check. You have to make sure that it's not shorting out to the shaft. So that's good. That's good. And that's good. No shorts. Okay, so I know my armature is good. You can also check the coil, but you're really not going to read anything unless you had like a super sensitive meter. But anyway, that should be pretty much ground. It's just a piece of wire, admittedly a lot of it. But, yeah, so that seems good too. Okay, I did want to show you a bad armature. I just so happen to have one here. And it's kind of funny too, they don't really burn out that much. Like I say, this one is extremely tough to buy. So let's check this one out. I'm going to zero my meter again. Go from one to the other, nothing. Go from that one there to that one, nothing. See, I have it marked in red already. Go from here to here, and that one's working. So that means that this one is bad. And like I say, there's basically nothing you can do about it. I mean, like I say, you could buy a new one. There are people that rewind these. I have no idea how expensive it is. So anyway, that's my bad armature. Okay, so I guess we can start putting this motor back together. As you recall, before I took it off the brush plate, that it was shorting out to the frame or very close to it. So what I did was I took it off and I very carefully bent these tabs, sort of tightened in here, and the whole plate was a little bit off. So I just lightly tapped it in sections, and I think I got it pretty good. Now I hope you can see this. Yeah, maybe. But right now, it's not hitting. You see that clearance there under the screw in the frame? And actually, the brush gap looks pretty good too. Okay, so let's put this together. Get my little keeper screwdriver. Okay, you don't want to make them too tight. You don't want to ruin any threads in these motors. I've done it myself a few times, and you got to retap them, maybe oversize them. So just make sure they're not too tight. Then let's check our gaps here. Ooh, this one barely makes it, but it's good. This is real tough for you guys to see. But actually, this brush holder looks like it's a little bit higher. So anyway, I just want to see if it works. We can fool around with that later. I might wind up putting the shim in here. But usually the shims doesn't do any harm. I've ran them for hours with shims in them. Okay, now come one of the biggest pains. Getting this brush into the brush holder. Other guys do it different ways. I found this to be pretty much good most of the time. Get yourself a small pair of tweezers. Reach in there. You can grab the spring and hold it. Hopefully you don't break the spring. But like I say, they do make springs when you buy a set of brushes. Usually they come with springs. Alright, that one went in fairly easy. Make sure the spring is in the slot. Okay. Let's try the other one. I know this is hard to see, but really can't think of any other way to do it. I am going to pull that spring up also. Come on. Okay, got them in. Like I say, make sure the spring is in that slot. It holds it nice and tight in there. And I guess now we are ready to do our test. The whole point of this video. Okay, I guess we're finally ready for the big test. This is a small Lionel transformer that I don't know, puts out probably around 18 volts or so AC, and we're gonna hook it up just like the drawing I showed you earlier. The blue wire is my top brush. I'm going to put power into that brush from my transformer here, my little alligator clips here. Okay, now, and remember, I did that because normally this comes from the roller, but I'm not ready to take that out yet. And so normally it would go up that roller, up this wire to a brush on these motors. Okay, now out of my other brush, remember, I want to go to my stator coil. Another wire I am going to have to put in new. But let's just wrap this around here for now. That ought to be good, I hope. And then we are going to take the other side of our transformer and put that to the ground, which is the frame of the motor. There you go. All right. Now remember, let's just go over this one more time. From the transformer, my blue wire here, into one brush, out of the other brush, into the stator coil. And remember, the stator, the other side of that coil is grounded, and that's going to my black jumper wire here. Alright, let's see if she spins. Ooh, there you go. You can see it a little better here. Yeah. See that motor on the other gear spinning? There you go. So, now I know this motor is worthy of rebuilding. Like I say, that armature is the heart and soul of it. You can look in there and make sure that your brushes are spinning fairly even. Now, if this wasn't to work, I would start checking for grounds. You can take your voltmeter and go to one brush and then to the other brush and then to the top of the coil, and you should have whatever voltage you're putting out of your transformer. Okay, so that's about it. Let's see, I do want to go over a few things. Okay, before closing, I do have to point out a few different things about Lionel motors. A lot of these engines going forward and reverse. Now, what I just showed you, I only had that hooked up for one direction. On this type of motor, like I said, these humpback motors, when they wanted to make it go different directions, they put something in it called like a rotary switch. Looks something like this. See if I can get that better. And it would mount on the motor here somewhere. You'll see them at different spots. But for the purpose of my test, and if you run across this, if I was you, I would cut the wires and mark them, and then go back to my drawing just on the brushes and that to make sure your motor works. That's just easier. I took the easy way out, and usually when I do buy a motor, I find the motor somewhere and it has one of these. That's what I'll do just to make sure everything's going to work. On different types of motors, I don't think on this one too much, maybe. But on other type of motors, you will see this is another one that you will see typically on this type of motor here. It will mount on the back here somewhere, and that's another thing they use for changing direction. Now, the most common is what they call an E-unit. This here does the same thing as that switch, only it does it electrically. Well, the second one did it electrically also. But this E-unit, it cycles on and off with power, and the engine will go one way or the other. Now, these things can be rebuilt too. I'm probably going to do a later video on that. But you'll see these on, here's one I have here. This here is an E-unit in an old engine I have, and it's actually got a little pull where you could lock it out. And that's also a different style motor. But like I say, yeah, I just showed you the easiest motor, and I think you can see that, yeah, they're pretty simple things. So I guess that's about it. One more thing I wanted to say about those other units, that rotary switch, this E-unit, and the pendulum unit, all they're actually doing is changing the brushes. So the power goes in one brush from the roller, the other way it'll go in the other brush from the roller, and the little, you know, just reverse the wiring. You'll see, as long as you look at the diagram that I drew. Another thing I want to mention before closing is all three of these are series wound motors. Lionel made series wound motors by the millions probably. Later on, I believe in the 50s, maybe even the late 40s, after World War II, which they call the post-war period, they started using some they call double wound motors. They will operate a little bit different, so that will have to be a different video. So, I guess that's about it. In my next video, I am going to show you how to take off one of these bottom plates, what to do about the rollers. I'm going to solder a new wire on, and probably on our original motor, I'll probably solder a couple more wires on. Alright folks, thanks for watching and have a good day.